All right, so we talked about the fact that whenever you're dealing with linear equations, again, linear just means that the equation is going to be a line when you graph it, a straight line. Talked about whenever you did that, there's really two different formats for those equations. One has the y all by itself. One has the x and the y on the same side, and then there's just a number on the other side all by itself. Again, it's called slope-intercept form, standard form. You graph them in very different ways. A lot of people on the exit ticket got the ways flipped. Like they tried to graph this equation by doing the y-intercept and the slope, the rise over the run thing. Can't do that. It's not possible. No way, no how you can do it that way. So they got wrong. Got everything wrong. There wasn't really much partial credit on that one anyway. Well, that's not true. There was, but if you tried to do it this way, there was no way to get partial credit. So remember, if the y is by itself, that's when you find the y-intercept and do the rise and run thing. And you shouldn't have to remember it. That should be in your notes. How many people just wrote that down? 0, probably. So if you don't automatically understand how to graph it when you see this equation, you need to write an example just like these. You can write the letter one and then underneath it write an example and say, to graph this, and you can even say when y is all by itself, use the y-intercept and rise over run. And I'll say that 2 or 3 more times. I mean, it says it right here. So you just need to copy those 2 down and then write that. So again, when the y variable is all by itself, you graph that type of equation by using the y-intercept. And again, if you need to write all of this in, the y-intercept is this number, including whatever the sign is right there. Then the rise over the run comes from the slope, this number. So the rise over the run comes from the slope number, which is the m value. To graph this type of an equation, this is where we do the whole T-chart thing. And we said we can always do this to graph any line. We can plug in a value for x and then solve for y, or plug in a value for y and solve for x. But the reason why this is kind of a special situation is we're always going to plug in 0 for x, then we're going to solve for y, and then we're going to plug in 0 for y, and we're going to solve for x. Let me do one thing real quick. Put it above. Yeah. So in order to do this, we'll kind of use this as an example. Remember, the equal sign separates the left and the right side of the equation. Doesn't matter where the equal sign is, it always separates. That's what splits the equation into a left and a right side. If I plug in 0 for x, I'm going to substitute in 0. So x is no longer x, it's now 0. I know what it is. What would y have to be to make the left side equal to the right side?
0.
Nope. What's the right side equal to? What's the right side equal to in the equation? I'm doing this red equation. The red equation, what's the right side of that equation equal to? 12. It's 12, whatever's over there. That's what it's equal to. The right side is the number 12. We need the left side to be equal to 12 also. How do we get, if x is 0, what does y have to be to make sure the left side is 12? All right, so we're not getting it. I'm going to slow down. And I didn't necessarily expect us to get that. I just wanted to see, because we've already done this for one full class. Here's what we're doing. This is the equation. I'll use green still. Here's the equation. Ah. Again, the left side and the right side are determined by where the equals are. In this particular type of equation, the right side is always just going to be a number because that's the way it's set up right here. The right side is always just going to be C, which is just going to be a number. So not really going to be a whole lot of different types of equations you need to worry about. So we need to make sure the left side of this equation, when we do the math, whatever's on the left side, we need to just make sure that answer is also 12. Well, the math is going to be 3 times x. Because remember, that's what 3x means, 3 times x, plus 2 times y. Because again, that's what having a number next to a variable means. We're multiplying them. And then that has to equal the right side, which again is always just going to be 12. We're ever going to change the right side. It's always just going to be 12. So again, I'll ask you again, see if that clarifies. If x is equal to 0, what would y have to be to make the left side equal the right side? Just the y. I want just the y to be something. The whole left side has to be 12. But what does just the y have to be? One person got it. Do you have a question, or you just?
Do you want to say it?
No, actually, I kind of like what you do. I used to use whiteboards for this, so that I wouldn't get a loud answer, because then everybody just said the same answer. Anybody else have it? All right, I'm gonna give you the next step. No, you're kind of on the right track, but let me give you the next step. So I said x is going to be 0. I'm gonna say, well, what if x was 0? Or I'm making x equal to 0. Well, if x equals 0, then I no longer need the x. I put the 0 there. So now, so that's for you, Mariah. But it says at my convenience. I'll let you go in a minute as soon as I turn it over to graph. Now, what would y have to be? So does that help anybody else? I'm just going to keep doing baby steps until finally I see where the light bulb is on. There, another person got it now. What would y have to be in order for the left side to equal the right side? And I've already made x equal to 0. I took the x out, right, and I made it equal to 0. Everything else is the same.
Have to divide it.
Well, divide what?
Divide the 2. Right, so
There you go. There you go. So what would that be? You're saying 4.
6.
There you go. All right. So now we got a few people. I'm going to go ahead and finish it off. I need what is the right side equal? Again, Nicole, you haven't been here, but I'm still going to ask you. What's the right side equal? The right side of that equation. What is it?
6.
Nope. What's on the right side?
12.
Well, that's what it equals. It equals whatever the number is. When I say what does the right side equal, that means do the math on the right side. Well, if there's no math, it's just a number that's there. That's what I mean when I say, what does that side equal? It means do the math. What value do you get? What answer do you get when you do the math on the right side? And then when I say, what does the left side equal? I mean, do the math that's on the left side, and whatever answer you get, that's what the left side equals. So the math on the right side is just 12. It's always going to be 12. So Shayla, what does the left side need to equal? It needs to equal 12. So how do we get 12? So this is going to be 0, right? 3 times 0 is 0. Plus 2 times y, which is what we're trying to figure out. We're trying to figure out what number does that have to be. What does y have to be in order for the left side to also equal 12? That's 6. And the way you do it mathematically is, remember, our last step of solving for a variable is divide. We just divide both sides by the 2. So we get y, so that goes away, so we still have the y. So that's how we get y equals 6. But basically what we're trying to come up with is what number do I have to plug in so that when I do the math on the left side, it'll equal 12, because that's what the right side was, 12. Well, if I plug in 6 here, 6 times 2 is 12. So that's one of the 2 points. So now I want you to figure out what would the x value have to be if y was equal to 0 instead of x being equal to 0.
4.
Well, I want you all to, again, don't just go with what somebody said. You need to, that person is not taking the exit ticket for you on Friday. You need to take a minute and make sure you know how to do it. So try to do that same process on your own. I'll give you a minute and then I'll kind of start doing pieces of it so that if you're lost, you can kind of catch up. You'll be doing this in a second on the graphing paper, so don't think you're getting away without doing this. You might as well try it. Right now they won't, but they're about to start. Do you feel comfortable with graphing? Because they're about to start doing graphing. Yeah, because as soon as I finish this, they're going to start doing it. You can look at this if you want. This is the sheet we have to do.
Thank you.
It doesn't. I don't have an answer key or anything, but if you have questions, you can ask me as you walk around. All right. So first step. If I'm making y equal to 0, oh, again, I could rewrite it as this. It's not a bad idea. 3 times x plus 2 times y. The formula or the equation does not change at all. Still the same equation. We're just going to change the y variable this time instead of the x variable. So if we're going to say, well, what if y equaled 0? What would x have to be? Well, let's see. Let's plug in 0 for y. All of this still stays the same, 3 times x. Again, this is still 12. That's never going to change. So I just need to figure out, well, what would x have to be to make all of my math over here equal 12? Because it's got to equal 12, because that's what the right side is. So 3 times x plus 2 times 0 needs to equal 12. Well, this goes to 0, right? 2 times 0 is 0. So really, I'm just left with the 3. I'm just left with the 3 times x. Well, 3 times what number? Because x is, I don't know what x is. I'm trying to figure it out. 3 times what number equals 12? Well, I could probably figure that one out if I know my multiplication, okay? But if I didn't, I would have to divide by, I always put the answer there. Divide by 3, and then over here I divide by 3, and that gives me x equals 4, which some of you are saying. Because the only number x can be to make this side equal 12, if y is 0, it's got to be 4. Because 4 times 3 is 12. 12 plus 0 is 12. That's what we're doing when we do this standard form method. And then you would just graph these. So this would be 6, 0, and 4. Whoops, that's not right. It would be 0, 6, and 4, 0. Those would be the 2 points that you would graph. We also said there's one other method. I'm going to do this on the, you should have already done this problem, but I'm going to show it to you anyway, and then you're going to start graphing. So look at number 1 again. You probably already have it done, but I'm going to go over how. I'm sorry, it's number 7. It's first problem. I always call it number 1. Okay, so it's number 11 because it's the second page. I'm not going over the first page, so I feel like you should be able to do that. The slope, the y-intercept, and the rise and run. Second page, the first one should be number 11, I think, right? Second page, number 11. There we go. All right, so just turn the page. Look at the second page, and you'll see what I'm talking about. Yep. There. So I'm going to do this a little bit shorter version. It's the same exact thing I just did, plugging in the 0 and then solving for the other variable. If I plug in 0 for a variable, though, if you'll notice, because of the way the formula is set up, it's a times x plus b times y equals c. Every time I plug in 0, because I'm doing multiplication, right? Every time I plug in 0, whichever variable I'm plugging in 0 for, that whole term just goes away. It goes to 0. So I can kind of take a shortcut and say, well, if I'm making x equal to 0, like right here, I'm going to make x equal to 0. Well, that's just going to go to 0. And that's just going to go away. You guys weren't here, so pay attention to this. If that goes to 0, I really just have to solve this equation right here. Negative 5y equals 15. So I divide by 5. I'm sorry, negative 5. Divide by negative 5. And I get y equals negative 3. That's where I put my first coordinate point. I just go to the y-axis, and on negative 3, I put a point. It's the same exact thing we just did when we did the t-chart. Same thing. It's just a little bit of a shortcut here, which I don't always like shortcuts. Actually, I don't like shortcuts, unless you understand why the shortcut works. So now I'm going to do the same exact thing, only this time, if I made y equal 0, well, if I made y equal 0, this whole thing would disappear. And now I just solve for x. So if I solve for x, I divide by 3, divide by 3. Well, that means I get x equals 5. And I just put a point on x equals 5. And now I have my 2 points. So all you need to make a line is 2 points. So it went through 0, negative 3, and 5, comma 0. If I would have plugged in, made the t-chart and plugged in 0 and solved out and gotten negative 3, then plugged in 0 for y, I would have solved out and gotten 5 for x, I would have come up with the same exact line. It shouldn't matter which way you do it, but you should always get the same answer. So that's kind of number 11 done for you. Same one I did last class if you were here last class. All right, so your assignment is you need to work on the 2 graphing pages. I'll show you in a second when I want you to do that. This is your exit ticket. I mean, not like literally right now. I'm saying on Friday, I'm going to give you graphs because they're going to be just like these. You can do them today. You should be able to do them on Friday. And there will be a word problem, like I said. There'll be one word problem where you have to create the equation and then solve for one possible solution. So I'll let you work on that. I'll walk around and help. Those of you that were not here on Monday, I'll try to do it on your own. I'll walk around and help you guys a little bit more, maybe. I'll help everybody. Oh, this one you can't do that way. You can do this one that way. 3 plus 0x. You can't, like you already have x. The only way to do this one is you just have to understand. So these that are circled out. Oh, you already changed them? Look at me. Well, oh, okay, so that one you did change. So 12 looks good now. Well, if I plug in, so let's say I plug in 0 for x, right? That all goes away. That negative sign is still there. Negative sign is there. There you go. Perfect. Right. Beautiful. Come back in. Now this page is the y. Again, on the first page, the very first page, you should have written use the y-intercept and the rise over run. If I walk by and you don't have that, I'm going to keep moving because you're not paying attention to me. So on the first page, you should have written, last time I say it, it better be on your paper. Use the y-intercept. If you spell it wrong, you spell it wrong. I'm not going to walk up to the board and spell it right. And so use the y-intercept and the rise over the run. That means you're going to write down the rise over run, write the numbers next to it that go for the rise and run. You have to change it to a fraction. You put it over 1. Yep, you can start that. So you can put your phone in the basket, please. You figure it out? Right. If I make x 0, right, that means x just pretty much goes away. What is y?
Right.
Well, that would be 1, and that's you still have 1 y. Y would be y would equal 3. So if x is 0, y should be 3. There you go. You just put it. So now look at your other. And I would really like you guys to be able to do up next. What's negative 4 divided by 4? You can. You can. Well, do the same exact thing. All right, so I keep getting this question, and again, I'm glad somebody's asking it because nobody asks it in most classes. If you're struggling with the problems like number 13 or even number 14 maybe, because you're like, well, wait a minute, I don't know, what do I do, what do that's different. It's not different, it's actually easier, frankly. But if the fact that there's no number in front of them is bothering you, what number is actually in front of them? Put a 1 in front of them. 1x plus 1y. Now you follow the same exact steps. It'll take you one extra step that you don't really have to do, but it'll get you to the right answer because it's the same process. Did you look at this one? So, you have something for another class? Did you finish all the equations?
No.
Did you what? Oh, good call.
You said this Friday, right?
We'll do it in a second. So for x equals 5, you still need a line. How would you create a line?
You have a slope.
Well, I need a question from you. What's your question?
What is that?
Oh, the bathroom, oh, that's what you were asking about? You don't have a whole lot done, so you're working on that.
For example,
When, I think somebody's actually after,
1.7, look at slope, right?
Mariah, or maybe nobody's after.
You're right, it's a 2 now.
Okay, you think you're next. Oh, no, Mariah wasn't after that.
Right? We over 1.
Alright, so let's see how you do.
Okay.
So I was just gonna say, better have that written
You
down.
have 1, yes.
Alright, so what I need you to do.
1.
Alright, if you're struggling with the first page,
And 1 and 7. And you have
this is what I want you to do. Oh, you should have this from the first page also. The plus run, or a positive run number means right. Oh, and you may want to write rise over run like that, just so you remember that's the slope. Negative run means left. Positive rise. So a positive rise means you go up. A negative rise means you go down. So write all that down. The rise over the run, you get that from the slope, which is the number next to the x. Not the x. The x is not part of the slope. Hopefully we remember that. So the slope is the rise over the run. So that's why I wrote 3/5 next to rise over run. And that's why I went to the right 5 and up 3. If you're still struggling with it, for every problem except for really 8, I want you to go through and pull out the slope, which is the m, and then the y-intercept, which is the b. You have no idea what to do. Pull out the numbers just like I did there. And tell me what the numbers should be, and we'll work on the graphing now. Again, just now you said instead x equal to 5, x equal to 5, and then you said, oh, what is x like? Always, right? X is always got to be equal to 5. The only way x is always equal to 5. Right? What is x equal right here? Nope. 5. Okay. 5, right? What's x equal right here? Right here. Matter? That's the only place x is always 5. Everywhere up and down. So that's always a vertical line. And it goes right through the vertical. This you can actually change into the equation. How many x's are there?
Right? What? It's negative. Negative will be, it's easy. Find it on this line.
So how many are there?
Right. It's your first.
What the number represents one.
Oh,
0.
So y, we have how many x's?
And this direction. For this direction.
How many x's?
Oh,
We have
okay.
0.
It's
X's,
positive and positive.
Good.
And now how you do?
Now you can graph this using the same.
1, 2, 3, 4, 5. Yes.
5.
Completely. Right. Different.
Well, you went down. So you assumed it had to stay on the graph.
It's 2 numbers.
You actually go up.
You have only one.
Because remember, this is a negative slope. This is a negative slope.
3
These are positive
over
numbers.
1.
That's a
So,
positive
yes.
slope. That's a
It
positive
means that
slope.
you will have 3 and
That
1.
can't be right.
Okay? In this
So
case,
you need to figure out, how do I keep that on the graph? If I can't count 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. I know it's somewhere up here. but I don't know exactly where it would be. So that's where you could say, well, wait a minute. But if I know it's somewhere up here, right, then that means my line would somehow come down through here. Right? It would look something like this. So how would I find the point that would be up here?
This number?
Probably somewhere in this general area. How would I find it exactly?
You're supposed to find it on this line. Where is negative one? What? It's your first point. First part of it. You don't need to find anything. This is slope. What is the slope? When we move from one point two way. The first way, I call it width and width, or width and width, depending on slope is it. In this case, it's 3 over 5.
We'll go up 6.
1, 2, 3, right?
Ooh. That's working on the graph, and it's still using the 6 number, which is the up and down number. So then what grade?
3, 4, 5.
Down 6 is what comes over here, not in that circle.
And it's like,
So mathematically, what you're doing, this is positive this way.
yeah, 3 over 1, same.
Isn't this still
Negative
positive?
is the first one, this one.
Negative is not by negative, it's still positive.
Instead of 3 over 1, it's 5.
What you're doing is you're actually changing the sign for both of these.
And this
Negatives stay positive. Positive over all numbers.
is
Well, now though, if this is a negative running to the left.
negative.
Negative.
From the point that you started on.
Yes, this
If
is
you do
starting,
that,
it's
you
negative.
run all the way.
Okay, yeah.
Yeah. It's even right,
Yeah.
We'll
What
show
is
you that.
it? When it's white, it
Because you need to convert this to a
Where is the
fraction
white?
first.
will.
You just do it straight
This
through.
one, it's your point.
That's not-
Just point.
You need to make this into rise over
You
run.
don't have anything else.
Make it into a fraction.
Zero.
You do like this. Putting it over 1. And now you have two numbers. You have a run number, which is 1. But it's a rise number.
Okay,
which is
So
zero.
this one.
So I want you to change that one. Look at your other ones. They may not be right.
And
All right, so for each of these,
Oh, wait.
this equation, how many x's
If you
are in
move
this?
it down, you move it down.
0, right here.
then- Right.
So
Negative
this
four,
equation is
negative
actually
one,
y
right?
equals
Because
0x. Your
Negative
ornament.
4 and
Plus
negative 1.
Right, that equation, y equals 0x plus 3.
And left, because it's
Yes.
also negative.
So now you treat this the exact same way as you treat all these, in the way we did that. So what I want you to do for all, even for this one, so for these 5, I want you to tell me what is the value of m in that equation, and what is the value of b. So for each one of those, we're going to do each one of those. I'll be over there in just a second, Frankie. Like I said, that first thing. All right. That is probably the harder page, the second page, but you will have problems on like the first page.
Why? Equal? No. It means it's every one. Now you have to, you will have one. And it is 0, right?
Oh, so again, right? I want you to follow that. Oh, you did. You got it right there. So is run left or right or up or down?
First one is 0, 1.
Or more importantly, is rise left or right or left?
Oh,
Rise would be up and down. Right? An elevator rises up and down.
That's fine.
Run is left and right. I think when you did it, you flipped it
Yes.
around. So go back and check number 1, which means you probably have to check some of the others. Okay, so same concept. You're confused. Why?
that starts at 5, right?
Mhm.
You have here.
So what happens when you try to do it? Goes off the graph, right?
Move in this direction, right?
So here's
One.
2 ways.
That you're supposed to-
One is the intuitive way, like you count in and out, which I love students to be able to do.
And
So, show you.
why the 0 you
So
do
if
need
I
to
tried to
know
do
when
this
you
way, I
go.
should. I
Okay,
go
now
1,
you have
2,
2 points and
5, 1, I go, oh crap, 2, 3, 4, 5, 6. I'm like somewhere up here. Clearly, I don't know exactly where, right? But
Let's see.
if that was my point, which is something, my line would slow down.
Where go?
Well, if I kept going, my point would be somewhere like down through here, right? Can you figure out where?
Yeah.
Now, just a little bit before
From here.
the easy for you. 0, all right?
Did you do the first page already?
That's 0. And this is, let's see what you will have. Here's the signal. So here's right? And this is that.
2, 1, 2, 3,
Positive.
perfect.
2, 1, equal to
Sure.
Now, you don't need to have this 2. Okay, why it's supposed to be simple without
It's
a.
you.
What you can do is.
Fire.
It will be simple. What you can do is. It's easy to read.
Yeah, if you have any work, definitely turn it in. We're gonna spend some time before break, like probably one day.
Division, right?
We're gonna spend some time making up missing grades. A lot of students have turned stuff in. We'll probably take a day.
Opposite division.
Something, not everything. Sometimes I check them in class. If you finish running early sometimes I'll just give you the credit. But if people haven't finished in class, I say, yeah. So that first page is outstanding. Oh, so yeah, this page, we don't solve it by doing any of this.
2y,
Um,
you divide by 2 equal what,
Well,
right? Because
I think you're, it looks like you're
right,
writing some
right,
track.
so it'll be
What
1.
you're writing?
1 times y will be y, right?
No. Actually, divided.
But you're supposed to do say divide it by 2, then 6 divide by 2.
Let me look at his real quick and then we'll come back.
Great, and this will be a point.
Because I want to spend a little more time on these first two. That's better. Good.
I struggle real hard to get that out and then dump it on the ground.
No, these are, you have a negative slope on these, but you can't be right because this is a positive slope. If it slopes down from left to right, that would be negative slope. Negative slope. So that can't be right. Also, on this one, you're just going from the 1 to the 3, from 2 to the 3. That's not what you do. You need to write rise over run. And you need to change this number 3 into a fraction. How do we change the number into a fraction? We divide by what?
You understand how to make my
No, so 3 over 5 is not equal to 3. It still has to be equal to the number 3. The value. There you go, perfect. So you need to write rise over run. And then you need to put next to the rise over run 3 over 1. Now you have a run number. What was your run number? Well, no, you okay, so let's just ignore that. If you wrote 3 over 1 right here, what was your run number? 1 is on the bottom. The run is on the bottom. 3 would be your rise. So from this point, you would go, and again, a positive run means you go right. So you would go right 1. Positive, oh, you even think that's supposed to be positive. Positive rise would be up, so you'd go over 1. That's kind of. Let's let it. Right, left. So the mathematical way behind that is a positive number. Positive slope. Isn't this also negative 5. So you're just flipping the sign of both of them. Changing it into this. Well, in negative 5 on the left, negative 6.
SpongeBob.
That's the math. By doing it. Right?
SpongeBob.
Good.
That's Elmo. That's Elmo. Elmo's the red. It's not Big Bird's the yellow dude. That is Big Bird.
But you got a negative, right?
Elmo's the purple dude.
Oh,
Purple dude.
That looks good.
Oh, that's nice.
If you understand what you did there, you're in good shape.
Barney's red. You're red. You're yellow.
Well, they're the same, they're the same exact thing.
Big bird. Want a kiss?
This is right, X would be 6. That one's right, now this. How'd you get those?
Sorry for having hang
Because
out.
it should be on the y-axis.
Still on sustenance.
Both of your points, one point should be on the x, one point should always be on the y. How did you get to 6? No, see, that's not always true.
ASI.
One that is bigger. Well, let me show you this part first. Here's what I want to set up. Borrow that.
Nick Robinson can't box.
You know what I mean?
Take out one round, bro. Maybe helps in the round swamp.
That's fine.
I'm just gonna come up with this value.
Bro, I was hoping that I was waiting for Tyson to do boom, put it out. It didn't fall out. I'm pissed at Tyson, bro. Yeah.
How about you?
How much money I paid for that? I watched it. How much money I paid to watch that? Okay, tell me, no.
I can pick whatever value I want as my first value. I can pick a value for x, I can pick a value for y, I can pick whatever I want. Then I have to solve for the other variable. Yes, I have to solve. Well, I'm gonna pick 0 and 0.
Oh, no.
I'm gonna pick 0 for x. Mainly because it makes my math easy, but I'm also trying to find the value of the variable on the y-axis
I think
and on the x.
it
And you
should
gotta
have
have 0, which is what we learned about intercept. Intercept has to have 0. So, if I plug in 0, here's my question.
You don't need to.
If I plug in 0,
I didn't even realize.
what's
This
this?
is like 2 hours.
I'm saying plug in 0.
You literally flipped.
Right,
I know.
exactly.
And I'm like,
Close, but what did I
Run
just say?
through. No, when I come back from DeAndrea, you go to her. That's just the 2 classes. One is electrical, which is really great. My second year is this morning. When you have second year, yeah, you have.
You could literally. I think that's why I taught it in grade. So same thing here. Well, let's finish this with this one. So if x is 0,
That is
we
it.
need to
And then
get
I
the
got
on the left side and the right side. And the right side is always going to be 6. What is y? How would you solve?
You better be like that next year.
Y by itself? Yeah, 'cause this is 2
get
divided
that.
by the opposite of multiplication, which is division.
No, it's not one cat.
It's what we have left over, right? And y is here,
Or a shirt.
and
Or
we
a
have
back.
6 divided by 2. Y is 6.
And now.
And we can check, so if x is 0,
It
that
says
just goes away.
Panther.
I can't see from
2
this far.
times 3 is 6. So now we're gonna do kind of the same thing, only we're gonna plug in 0 and y this time. Again, you can write that way, so.
The heck, man?
What? I'm actually like 8 times. I like to use it. Confused when you're trying to thought it in. So if I'm saying y is equal to 0, that literally means that y is no longer in there. Now 0. Substituting in for 0, or for y. Alright, so what would x be?
In this
I don't
case,
think
you're supposed to call 2
It has to be 6, right? The only number plus 0 equals 6.
points for y.
And then these are coordinates. This is 0,
Yeah.
3.
Y.
And then come and do.
For 2
Go through and try to finish those up. I gotta get started on the rest of it.
Full start.
Oh, wait, going to 0 will be x will be what? 0. You put it down.
Breathe good. There. Now this one goes off. So it clearly would keep going down. So instead of going over one and up more, you would go over one this way and down. You want to try to put that on the graph. Same way there. Instead of going over and up, you try to figure out how far this way, which would still be 5, up and down. Good. Yeah, that's good. All right, so we got the new lesson. So we're not done for the day. This is the other thing that will be on the exit ticket on Friday. Yeah, it's in this same kindergarten.
22. Mariah.
Just in time.
What do you think about it?
All right, so. Okay, yeah, good, perfect timing. Thank you.
Less than 22 days.
I'm not trying to put myself in the
All right. So, oh, you need to come pick this up. That way you don't have to copy all this stuff down in your notes. Yeah. It is. This is very, very hard.
It is hard?
Not hard. You've already done it.
It's
not
super
new.
hard.
All right, so there's some there, so I split them up so you can grab whichever file's closer. We already did this. It's not new. I say it's new. It's not new. We did it 2 days ago. So is Lazaria a cheerleader also?
Well done.
Frankie, is Lazaria a cheerleader also?
Thank you.
I think she's a cheerleader. She's in one of my other classes. I thought I saw her. She's dressed up in a cheerleader outfit. Yeah. Actually, she's got to be a cheerleader. We don't have cheerleaders for anything else anymore.
Why not?
Sometimes,
I think I
probably.
know who that is. That's that one girl.
She's got to be a cheerleader for basketball because we don't. I forgot football though. So she can't be.
Don't they have 2 more games?
No, I think they're done. I thought they still had games too, but I just talked to one of the players and he said, no, we're done.
What?
Well, you know, football. Varsity lost, right? Yeah, they're done.
Lost 10 to 20.
I remember that. Oh, I remember that.
All right, so I'm going to go over the first couple of problems for you, and then you can do the rest of them. We already did this one actually 2 days ago. So I'm going to review it. This one's going to go faster than the next one. I'll spend a little more time on the next one, but we've already done this one. We said when we're creating an equation, now sometimes they'll tell you what kind of an equation. Like they'll say, create the equation in slope-intercept form. And if they say that, they'll say, create an equation that looks like this, basically. Or they'll tell you, create an equation that looks like this. So if they tell you that, then it's pretty easy. But they won't always tell it. So you may have to figure out, when do I use this one, or when do I use this one? So we said the key is you're looking for the slope, or you're looking for words that like tell you that there might be a slope. Any of these, each, per, in, every, in one. So for example, if you get paid $5 per hour, first of all, you don't get paid very much. But if you get paid $5 per hour, that is a slope. It's $5 per 1 hour. That's what you're looking for to figure out the slope in word problems. It's also called the rate of change, not just the slope. Then we said though, in some word problems, you're actually going to see what looks like it could be 2 slopes, which is not possible. You can't have 2 slopes in a problem. It's either just 1 or it's none, basically. If you think you have 2 slopes, then you have to use this right here. 1 slope goes here because we have only 1 slope in this problem. 2 slopes means you actually don't have a slope at all. There isn't a slope. So you're going to use this format. It looks similar, but there's not. You can't have 2 slopes. So for example, We did this problem and we said, well, we have 100-point test, right? Some questions are worth 2 points, and I'm going to change that word again. 2 points each, and some questions are worth 4 points each. A piece is just another word that means per question or each question. Well, we have those words twice now. We have 2 points each and 4 points each, or 2 points per question and 4 points per question. Either way, we have that twice. We wouldn't be able to pick one of those to be the slope. You can't just choose one. That's telling me immediately I need to use this format right there. So now I just have to figure out, oh, and A, B, and C will always be integers. That means they won't be fractions, they won't be decimals, which makes it easier. I just need to figure out, what does A have to be? What does, oh, and it's always going to be an X and a Y. That's always going to be in there. So you can just kind of write those down immediately. I just have to figure out, what is A, B, and C? What do you think C might be? What number would C maybe be? C is going to be the final, I like to call it the final number now. I moved away from total because it's not technically always a total, but it is pretty much always the final number. Well, the final number will, in this case, be the total number of points at the end of all the questions. Once I've done all the questions, the final number is going to be 100 points. Now I just got to figure out, oh, and it tells me that the X is related to the 2-point questions. So what does X stand for? How would I define it specifically? It's going to be about the 2-point questions. Some people love math class so much. It just makes them want to dance. They love it so much. What's that? Say it again. X is how many. Remember, when you're defining a variable, there's only going to be 2 options. Like, I can't even imagine a situation where it's not going to be one of these 2 things. It's either going to be how many of something are there, or it's going to be how much in one of them. In this case, we know how much one of them is. It's 2 points. Or over here, it's 4 points. So we just need to know how many of them are there. So how many 2-point questions, and they told you this in the question. They said X represents the 2-point questions. Right. How many 2-point questions? And then they told you that Y is about 4-point questions. But again, what would we actually want to write for Y? Yeah, Y. And again, I'm going to go kind of fast because this was the last lesson. It's recorded already. It'll be recorded again, actually. How many 4-point questions? So in this case, the variables are the how many part of the problem. Because we already know that how much one of them is. One of them is 2 points, and then that's the X's, and one of them is 4 points for the Y's. So now we just need to take the numbers from the problem, the ones we haven't already used, we used the 100, and we just need to put them with the correct variable in the equation we're creating. So what numbers have we not used in the word problem? Jasmine, what numbers have we not used? I gave you an easy one. We already used 100, so what are the other 2 numbers in the word problem? Pick one of them. Yeah, you can look at your sheet or you can look up here. The word problem is just this right here where it says number 1. It's only a 1-line word problem. That's the one word problem. What number? 4. 4, is that what you're saying? So 4, what is the 4 about? It's about which kind of question? Kind of a little tricky. It's about the 4-point questions, right? The number 4 is about the 4-point questions. Well, which variable is about 4-point questions? Y, right? So we just put the 4 with the Y. Simple as that. So the only other number then is what? Anthony. What's the only other number we haven't used?
2.
2. What's that about? 2-point question, right? So which variable is about 2-point question? So that 2 goes with the x. Simple as that. These, I do not think creating these equations are nearly as difficult as creating the rising
Like
and
a
running.
line and an X and where the thing's supposed to go?
Does it show you what it
Like.
Oh, you're on the next problem?
No,
we're in the same
on
one.
the first one. It says X equals and then comma.
Oh, yeah. I just defined x and y for you. They said x equals, and I defined, that's what we did.
Oh, okay.
The total would be the 100. Again, I like final number better than total. So, yeah.
That in here?
So x equals, and you would write in, it's not, you're not solving anything. Like, you're not trying to solve this. Not yet. Yeah, you can write on paper. Yeah. So they're asking you to define x in words, not solve. So we did A. So B is the last part of this. We actually did this problem the other day in class. It says for B. I have room to do this. Yeah. It says if you have 24 questions worth 4 points, how many 2-point questions would you do? Well, there's a bunch of different ways to solve this out. What's that? Well, let's talk about what we're doing. What if you just have one question worth 4 points? How many points are those questions worth? 4, right? What if you have 2 questions worth 4 points? How many are those worth? 8, right? So let's write that down. If I had one 4-point question, that would just be worth 4 points. I only have one of them. If I had 2 4-point questions, well, now that's worth 8, right? Because 4 plus 4 will be 8. If I had 3 questions, that'd be worth 12. I could literally do this all the way until I got to 24 of them and add up all the 4s. What's faster than that? Not dividing. Yeah, multiplying. Let's not add up 4 24 times. Let's just say 24 times 4. So 24 questions worth 4 points. Let's not add. Let's just say 24 times 4. So all of the 4-point questions on the test, if you add up all of them, you'd be multiplying 24 times 4. So you have 96 points that come from the 4-point questions. So there's only one other type of question on there. How many points do we still need to get to 100 though? We need 4 more points, right? So we're missing 4 points. How many 2-point questions make up 4 points?
2.
There you go. 2 questions are worth 2 points. So that's where we would have to divide by the 2 to get 2 questions. That's kind of like the intuitive way. Did we use the equation at all?
Yeah, that was actually.
Kind of did. You didn't know we did, but we did. We totally used the equation. Because watch. Look at the math that I just did, right? I just did that math right there. Watch this. You remember the equation? What was the equation? You should have it written down. 2x plus 4y equals, as Aaron said, 100. So they told me what in B? What did they tell us? There are 24 4-point questions. Well, that's what y is, right? Y is how many 4-point questions. So I don't need y anymore. They told me how many 4-point questions. I don't need a variable if I know the number. So I take y out, and I say, well, I know how many 4-point questions. There's 24 of them now. Now I can solve for x, because I have a variable and only one equation. If I have one variable, one equation, I can solve that. I get 2x plus 4 times that is 96, we just already said. So there we go. And guess what we do to solve that? So we just did 24 times 4, right? That's what we did up there when we did it intuitively. So we're doing the same exact thing in the. Now, in order to get x by itself, we would subtract 96 from both sides. Well, that's what we did when we came up with the 4. we subtracted 96 from 100. Same thing we're doing right now. And then what's our last step when we solve an equation? Well, isn't that the last step we did right there when we figured out how many questions? So you may not have actually used, this is why I tell you, you use algebra all the time. You just don't know you're using it. You're using it without actually creating an equation. But you're using it. Everybody uses math. So yeah, so we got x equals 2 questions. I'll get you started. Where's the... Oh yeah, here's a good one too. I want you guys to try, oh well, yeah. I'm going to give you one more example because you have plenty of them on the worksheet. I'm going to do this one for you. Again, it's 12 students can go on a small bus. Oh, they're going on a field trip. There's 432 total students, blah, 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 blah. We need to split those students up into small buses and large buses. The key is we can't have any empty seats, meaning we have to have an exact number of buses. So basically, you can't get a decimal when you solve it out. It's got to come out to a nice round number, an integer. So this is 12 students per small bus. This is 36 students per large bus. We have 2 words. We can't use the slope intercept thing. We got to use that ax plus by. So that tells me I've got to use this because I have the word per twice. Even though you don't read the word per in there, that's what that means. So I know I'm going to have the x. I know I'm going to have the y. I know I'm going to have the equals. Again, what's my final number got to be? In this case, it's just a big number again. So that made it pretty easy to know where that goes. I just need, oh, it doesn't tell you what the variables stand for, so you have to define the variable. That's the only tricky part. On the exit ticket, I'll tell you what it has to be, but I'm going to make x equal, and it's always how many or how much in one. Well, I know how much in one, 12 go in one bus, so it's got to be how many. So that's how many, I'm not even going to write students, I'm just going to write in a small bus. Oh, no, I'm sorry, not how many in. We already know how many in, 12 go in. It's how many small buses. How many of them. So I'm going to use x to be small buses. I'm going to use y to be how many large buses. I'll give you that on the exit ticket, so don't worry too much about that right now. Now I just got to match up the numbers with the variables. What's the number 12 about? Well, it's about small buses, but it needs to match up with x because x is about small buses. So I put a 12 there. 36 is about large buses. Well, that's got to go with y because y is about large buses.
That way you said ax.
There you go. There's your equation. Now, here's the tricky part. I said, well, what's one possible combination that we could do to make sure that we have exactly 432 students with no empty seats? So now it takes a little bit. Again, you could just kind of do the same thing we did before, and you could say, well, I don't know. Let me add up students in a bus until I get to 432. I could say, well, if I took one large bus, there's 36 students. And then I could say, well, if I took another large bus, there's another 36 students. I could keep doing that. I could throw in some 12 student buses, some small buses. I could say, well, let me add some 12s in there. Eventually, you'll come up with numbers that come out to 432. Like right now, I'm at 72. So this right now is 72. This is 36. Am I at 432 students yet?
No.
Not even close. So I'd have to keep adding buses. At some point, you'll get down to, like, let's say I did 10 buses. How many students would 10 large buses be? Actually, no, scratch that. Let's cited 10 small buses. How many students would 10 small buses have in total? 120, right? 12 times 10. If I had 10 buses and they have 12 students in each bus, that'd be 120 students. So 10 small buses is 120 students. How many students would still be left over? It was 432 total. There it is right there. How many students would still need to fit in the large buses? Yeah, 312, right? We put in the 432. I get 312 left. Who has a calculator in front of them? Anybody? Do me a favor. Try to divide those 312 students up into the large buses, which hold 36. What do you get?
This isn't working.
Alright, I got this.
What do you get? I know, right? I got a decimal. What does that mean? Well, it means we have empty seats. We'd have to add it because we have some leftover students that don't fit, so we'd have to add another bus, but then that bus would have empty seats. That's what a decimal means in this case. You need to come out exactly on an integer number so that we have a full bus. So that didn't work. 10 small buses didn't work. Let's try 10 large buses though. How many students would be in 10 large buses? That'd be 360, right? So let's see how many students would be left over then if we had 10 large buses.
12 large buses.
So that would be 72, right? That'd be how many left to get to the... Now, try figuring out how many small buses would fit into 72, or how many 72 students would split up. That come out nice and round? That came out nice and round, and that worked. So it would take a little time, but you'd be able to figure this out. The other way that you're doing it is you're doing this right here. Again, you're doing algebra, you just don't know it. Totally tricking you into doing math. You're really just creating this table. X, Y, picking a number for X. We picked, wait, X was a small bus. Yeah, so we picked 10. Do you happen to remember what number you got for the decimal number?
8.6.
8.6. So we got 8.6, and we said, well, wait a minute, that doesn't work. We wanted to come out on an exact even number of buses. That didn't work. Well, let's not pick a number for X, let's pick a number for Y. So we pick the number 10 for Y, and we plug in 10. We have 12X plus 36 times 10 equals 432. So this is 360. Still 12X. All right, well, we subtract 360, subtract 360. Up, 72. Divide by 12. So it's all the same exact steps you just did. You just didn't actually use the equation. Oh, and the answer would be 6. So when we plugged in a value for Y and solved for X, it worked. When we plugged in a value for X, it didn't come out exact. Now that number would have worked. Problem is, it would have given us an extra bus with empty seats. Because we would have had to have taken 9 buses, and that 9th bus would have had some empty seats on it. So on a test, on the exit ticket, what I'm going to do is I'm not going to just leave it completely open like that. I'll ask you, if they took 10 large buses, how many small buses will they need? So you would need to do this same math. Plug in the 10, multiply it out, and then figure out how many small buses will carry the rest of the students, or whatever the problem is about. So go ahead, I want you to work on, you got 20 minutes, I'm going to come around and give some grades in about 10 minutes. Wait, no, you got 15 minutes. So I'm going to come around in about 6 minutes and give grades for the work you did on your graphing and or the word problem, so if you'd rather work on the word problem, that's fine. But you should have some work done today. Don't show me a blank page. Yeah, I don't see what you're doing. Do you have some work done today? Because you've been napping a lot in class. So you need to get some more sleep, or you need to somehow get yourself awake for the class. Where are the worksheets? There we go. Let's see what you got on the worksheet. You may need to stay in here with this work. You don't have anything. So you have nothing on What did you do today? Your grade today is based on what you've done in class today. So I'm just staying here and work on either, you can do either the equations or the graphing, I don't care. Both of these will be on your exit ticket on Friday. The equation, or creating an equation and giving me an answer. Question? Go back and watch it's just solving two-step equations. Yeah, just like what we did from this point forward. Subtract that and then divide by that. Now some of them have fractions on it, which is a little trickier. So you can go back and watch the video on how to do the fractions, or if you just type in how to solve two-step equations with fractions, a whole bunch of videos pop up on YouTube. So I'll give you 5 more minutes and I'll start walking around. The exit ticket, we'll probably do a little lesson before a new lesson, not anything that we just did. So there won't be a review. We did all day today for a review. So make sure you are ready and prepared, because you're not going to see it again before the exit ticket. Yeah, I'll work my way back. You can make the on this thing when it says x equals and y equals, you can make the variable stand for whatever you want. So for example, in the second the problem about money, $5 and $1 bills, you can make x equal $5 bills and y equal $1 bills, or you can make x equal $1 bills and y equal $5 bills. The important thing is once you assign whatever you want to the variable, you need to make sure your numbers match up with the correct variable. So some of you may have an equation where the x is with a different number than somebody else, but you could both be right. It just means one person may have said x is worth $5 bills, and the other person said y is worth $5 bills. How many $5 bills? So you had a question, Shayla?
Oh, yeah. The probably not like this one right here, and then we get one.
Yeah, that whole sheet, every one of them. The whole word problem sheet, I'll just tell you, there's no y equals mx plus b formulas on that. It's all what we just did. Ax plus by equals c. So all you got to do is figure out what is the a, what is the b, what is the c. And you got to define the variables. That's the first step. Make sure you say x equals how many large buses, in my example. Y equals how many small buses, although I did it backwards. You can pick, whichever, just make sure you put how many. The key is make sure you say how many, or theoretically, I guess it could be how many in one, but that's very rare. Very rare. Let's see what you got. I do think 3 is a little bit easier. Well, these wouldn't be numbered though. These would be, it tells you actually, x is the cost of a thing, y is the cost of a salad. So it tells you what x and y are. In number 3, it tells you what x and y are. You may want to look at number 3 real quick, because I'm about to start walking around. It tells you let x be the cost of, and then I forget what it says. And then let y equal the cost of whatever it said. Yeah, I think y was the cost of the salad, x was the cost of the sandwich. So it tells you right there what you need to make x and y in that one. All right, so I'm gonna have to walk around and grade, so I'm not really gonna be able to help. But again, you got videos, you had the full lesson today. You guys online, all of this stuff is due from you no later than Friday. Some of you I think might have turned it in. Well, maybe not in this class. I don't know. For your exit ticket, I've got to get somebody in here to help cover my class so that I can ask you guys some questions. But I don't know. I'll get to that at some point. Oh, looks like somebody decided to leave. I'm gonna go ahead and stop recording. Hopefully I don't say anything super important at the end of class.